all right, buddy. It's all right now. It's all over. This is my Kenul patent, Mark II, and here's my setup. A magnet that induces flux through a iron nail or bolt, and we have coils, a drive coil or a cut-off coil here, and here we've got 3 pickup coils. Now, I'll just put it like that so you can see it a bit better. The theory is that we induce this coil, which has the same capacity or resistance, the same ohms as the other coils. And anyway, we cut off the flux from the magnet and then allow the flux to flow through again, and we do that 1,000 times a second. In a previous video I did, I think it was a low voltage DC pulse generator. Looked like this, and here it is, just a little pulse DC generator. This one, what I've got is a super high voltage, low current DC pulse generator. So the output of these coils go to a rectifier, and then I've got a load here which is a long LED lamp. So that's our load to test with. By the way, this rectifier is rated at 2 amps. I don't know if it'll be putting it out 2 amps, but anyway, you never know. And the input of this, okay, let's go to the input side. So here's our input, positive and negative. This is a momentary switch. And all I've got so far is that hooked up to this Chinese, this is a voltage multiplier, and this goes from, they reckon, 400,000 to 1 million volts. And I had a bit of a play around with it. Gee, it's pretty good. So yeah, that does the work of the high voltage generator, and that goes to our spark gap, which was from our old fly swatter, and that goes back into this cut-off coil here. So that will pulse along with the pulse generator and the whole system. Okay, so the only thing we don't have is we don't have that. We don't have a battery or anything like that just yet. The problem with having this setup is that I don't have a potentiometer on there to fine-tune the output like I did on the previous video. So on this low voltage DC pulse generator, we've got 2 potentiometers to play around with to fine-tune it, and that does make a hell of a difference. However, it's early days. As you can see, I've got plenty of other coils that are equal to the 7 ohms that we can add on to there if it's successful. I don't know if I'm supposed to have these diodes on here. I just read that it would mitigate the back EMF once the system switches off or in the negative phase. So that'll be interesting to see if that works or not. Well, it'll be interesting to see if the whole thing works, to be honest. So what we're going to power it with is just our power supply there, and we're just going to have the minimal amount of power required to actually cause a spark to occur. I've got the spark gap set pretty close together, and I'll measure. I think that's about 3 mil, so very close together. It makes a hell of a spark. It absolutely scares the living bejesus out of Maxie, doesn't it, boy? Hey, old boy. So for the sake of testing, well, we've got everything ready. We'll see how it goes. I can't promise anything at this stage. The actual information on that high voltage generator is quite sketchy. Some places say a minimum of 3.7 volts, and some say a minimum of 5 to 6 volts. So I think we're just going to go for 4 volts to start with. Our current, I'm allowing 30 milliamps. They say 50 milliamps to 500 milliamps. So I'm just starting on the lower side just to see what happens. Obviously, the less power we use, the better, to induce that number 1 coil, the cut-off coil. That one. It cuts off the flux of the magnet. Let's see if it works. Let's start up, see what happens. All right, we're on. Let's push the button, and we got 2 parts of nothing. All right, we must be below the threshold. All right, in order to evaluate, I've connected it to this LiPo battery, and I think I might have found a problem. If I push the button, you'll see in there something to do with my coils. That first coil, we'll have to take it off and have a look. Righto, so it appears maybe I've got my connections around the wrong way, so I might swap them over and see if that makes a difference, and also check this coil. So it looks like the problem's right here at the start. Let's see. Yep. Definitely is a problem. Might have to insulate that or cut it or something, I'm not sure. Yeah, what to do. Pretty amazing though. Plenty of power. It's not huge. It's not a huge magnetic induction. You can see the movement of the compass. Okay, so what I did was I opened up the space there. Hang on a sec. So I've opened up that space to about 5 mil gap, and that's made a hell of a difference. And also bucket up our coil again, because watch this. It's huge. I'll just open that up a bit more, I think, see what happens. Okay, how to bugger up your coils. I've got it at 1 centimetre, 10 millimetres approximately. Let's have a look, see what happens now. It does make a hell of a difference. Let's keep our eye on the on that as well. Man, that's just going off. That's funny as. Yeah. I reckon that's pushing it a bit. Anyway, so clearly it's very fine tuning of this thing to make it work, but just thought you'd get a bit of a laugh out of that. And yeah, let me know your thoughts. Thanks for watching. Catch you later. By the way, the reason I'm using these electrodes, and here's an example, is this is actually electric fencing connection wire. It's made for electric fences, super high. It's made for super high voltage. You can see it's very well insulated, so relatively low DC but very high voltage, and that's why I've chosen that. And you can get that from any rural store. What's also interesting is I've got the voltage up to 7 and current up to 1 amp, and still I got nothing. So anybody want to enlighten me on that one?